and I'm going to continue another topic relating to problem-solving reasoning. My topic is all about problem-solving strategies. So let's proceed with the 4 problem-solving strategies. First, we have guess. These include or stands for 2 strategies: guess and check and guess and improve. So guess and check is one of the simplest strategies because anyone can guess an answer. While guess and improve is, for example, your first guess is incorrect, so you can able to improve your next guess. That's guess and improve. So another example, or mostly example, of guess and check and guess and improve is jigsaw and crossword puzzle. Next strategy, or the second strategy, is act it out. Act it out and use equipment. This strategy is an effective strategy for demonstration purposes and to have a better grip of the problem. The third strategy is draw. It includes drawing pictures and diagrams. This strategy most used in physics, trigonometry, chemistry, and another. This strategy is often a good starting point for solving of all kinds of word problems. So the last strategy is list or tabulate. This includes making a table. In this strategy, it could help us discover hidden hints towards solution of some problems. The examples is finding patterns and arranging data in descending or ascending order. Another topic is about mathematical problem involving patterns. Patterns shows a repeated occurrence or something that follows a specific rule, and it shows how things are connected. Example, finding patterns. A series of rectangles where each rectangle is bounded by 10 dots. So the example is finding first how many dots are required for rectangles. Second, if the figure has 73 dots, how many rectangles would there be? So the answer is in the table. So let's proceed with the last topic. It was recreational problems using mathematics. Recreational mathematics involves problems, riddles, puzzles, brain teasers, and games carried out for recreational or leisure rather than as research or application-based professional activity. Examples are Rubik's Cube, magic squares, fractals, logic puzzles, and mathematical chess problems, and can-can puzzle. Another topic is data management. Under the data management, I will discuss about data gathering and organized data, representing data using graphs and charts, interpreting organized data. So data is a collection of information from facts, statistics, numbers, characteristics, observations, and measurements that represent an idea. There are 2 forms of data: quantitative data and qualitative data. Quantitative data deals with the quantity, for example, the number of the whales at the sea world. Qualitative data is another form of data that deals with the description of things, and qualitative data can be observed but cannot be measured, such as the color of your eyes or the color of our eyes. In gathering and organizing data. So how do we gather and organize data? There are several ways to obtain and analyze data. As a researcher, you can use the following: surveys, focus data using various charts and graphs. So in representing data, I only have example in graph, which is bar graph. A bar graph is a simple way of representing data. Bar graph is a method of representing data by drawing rectangular bars of equal width and equal space between the two bars. These can be drawn using horizontal and vertical bars. And in interpreting organized data, it is through reviewing data through some predefined processes which will help assign some meaning to the data and arrive at a relevant conclusions. Last topic is measure of central tendency, mean, median, mode, and weighted mean. A measure of central tendency or the central location is a single value that is used to identify the center of the data and or set of observations. And there are three measures of central tendency are the mean, median, and mode. So mean, also known as the arithmetic average, is the sum of all observed values divided by the number of observations in the data set. This can be calculated using the formula, and another mean or another information, the means of subgroups can be combined to come up with the group mean known as weighted mean. This can be computed as median. The median is a single value which divides an array of observations into two equal parts, such as that 50% of the observations falls above it, and the remaining 50% falls below it. And the last is mode. The mode is an observation that occurs most frequency in the given data set. And the other topic will discuss by Mr. Angelo Gragas.
So this is my first topic, which is the measure of dispersion, the range, the standard deviation, and variance. A measure of dispersion or measure of variation is a quantity that measures the spread or variability of the values in a given set of data. The most commonly used measure of dispersion are the range, variance, and the standard deviation. The simplest measure and easiest to compute, but a rough estimate for this measure of dispersion is the range. How to solve the range? Example 1. Compare the performance of the 3 students based on the ratings in percent. In the 5 long test. Solution. Student A has this value, data set of value, and the student B has the data set of value, and student C, this is his or her data set of value, which is all 80%. The mean of the 3 students is 80%, but in range they are similar. Student A has the range of 19, while B has 4 and C has 0. We can get the range from subtracting the lowest to the highest. For example, in student A, the range is 19. The lowest is 70% and the highest is 89%. If you subtract the 70 from 89, the difference is 19. That is the range. Example 2. The average daily allowances in pesos of 12 college students studying at the University Y are these data sets, these following values. We will going to find the range. First, let me arrange the data sets and get the highest and lowest. The highest is 165.5 and the lowest is 99.75. We will subtract them to get the range, and we have the 65.25. So the range of daily allowance of 12 college students is 65.25. Second, the standard deviation. Standard deviation is the positive square root of the variance. The variance is the average squared deviation of every observation from the mean. This is the symbol of standard deviation for the population, and for the sample, this is the symbol of standard deviation. For the variance, the symbol for the population is here, and here is for the sample. Variance is standard deviation. This is the formula for the population variance, and this is the formula for the population standard deviation. This is the formula also for the sample variance, and here is the formula of the standard deviation for the sample. Let's have an example. Example 1. The following are the score of the student in all her long exam in calculus: 83, 80, 89, 78, and 70. Calculate the standard deviation. Let's calculate. This is done by this. We have here the x and y, which is the data set or the values, and x, y subtracting the mean, and x, y subtracting, and the difference of this will be squared here. This is the value, the data set value, which is the xy, and this is the difference by subtracting the value from the mean. X value, the x value is 83, 80, 89, 78, 70, and the mean is 80. For example, in this 83, we will subtract to 80. The answer is 3. 80 subtract it to 80 is 0. 89 subtract it to 80 is 9. 78 subtract it to 80 is negative 2. And 70 subtract it to 80 is negative 10. And here we will going to multiply this to itself. 3 times 3, 9. 9 times 9, 81. 2 times 2, 4. 10 times 10, 100. And this is the sum. The sum of x value. And this is the sum of this. This is the sum, the 194. And the number of data value. 1, 2, 3, 4, 5. That's its y5. And the mean is 80. This is how you get the variance. This is the formula. We will multiply this 194 to 5, which is the product is 38.8, and square that, the answer is 6.23. I mean, the square root of this 38.8 is 6.23. This is the standard deviation. The standard deviation of the population is 6.23. The result indicates the average. The percentage scores of the student tends to deviate from the mean by amount of 6.23 units. Next, another example. The following data were obtained by sampling on a population: 2, 10, 12, 14, 15, 17, 18, 18, 24. Let's find the variance and standard deviation of the sample. This is for the sample. Solution. You have here the x value subtract to the mean. This is the mean, and square them. Multiply them to itself, and we have here the value and the difference and the product, and the total, or the sum of x value is 128, and the sum of this is 130, and the number of value is 8, and the mean is 16. This is the formula for getting the variance for the sample. Multiplying, dividing the 130 of 7, it becomes 7 because we subtract it by 1 because n is 8. So the answer is 18.75. And this is the sample This is the standard deviation of the sample. We square root them and the answer is 4.31. The variance is 18.57 while the standard deviation is approximately 4.31. Next, measure of relative position. Wait a minute. A measure of relative position, statistical measure that provides a specific location of an observation relative to the other values when the data are in rank order. This is the definition of percentile, quartile, and decile. Percentile denoted by p value is a py is a value that divides an array observation into 100 equal parts, in order that I% of all the observation lies below py. The quartile denoted by qi is the value that divides an array observation into 4 equal parts, in order that y multiplied 25% of all the observation lies below quartile 1 y. The decile denoted by dy is a value that divides an array observation into 10 equal parts, in order that y multiplied to 10% of all the observation lies below dy. Formula for this percentile. This is the formula for the percentile. For example, let's jump into example 2. Given the following data set, 25, 5, 6, 12, 8, 16, 17, 22, 20, 19, and 9. Compute for 20th percentile, first quartile, third decile. Solution. Let's first arrange them from lowest to highest. 20th percentile. Let's use the formula earlier, which is n is the number of value 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and y is what we are looking for. P20 equals 10 multiplied to 20 divided by 100. 10 multiplied to 20 is 200, and 100 divided by 100 equals 2. Look, 2 is the location of 20th percentile, which is the 6. This. First quartile. P25, 10 multiplied to 25 is 250, not 10. Divided by 100 is equal, but still equal to 2.5, which is P25 is located halfway between second to the third value in the list. So P25 is 7. Since quartile 1 is P25, therefore quartile 1 is 7. Here, between 6 and 8 value. Third decile. P30 equals 10 multiplied to 30 is 300, divided by 100 is 3. Therefore, D3, decile 3 is 8. This 8. Box and whisker plot. A diagram showing the representation of a 5-point summary of a dataset specified by the lowest and the highest values and the values corresponding to quartile 1, quartile 3, and the median is called a box and whisker plot, also known as the box plot. This is the diagram of a box and whisker plot. The measure of relative position to help us to understand the relative position. Next, let's make a box and whisker plot. First, we should arrange the datasets. This is just a sample dataset. First, we will get the quartile 1 or the P25, and the answer is 8, which is the third to the lowest, and second the median. In getting the median, we will count the datasets or the value 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 datasets. So we will subtract the the x6 and x7, which is the 1, 2, 3, 4, 5, 6, the 12 and 15, and divide them to 2. 12 plus 15 is equals to 27. Divided by 2 is 13.5. Our median is the 13.5. Quartile 1 equals P75 is equals to 12 multiplied to 75 and divided by 100 equals 9. The quartile 3 is the 17, the fourth to the highest. We get this 3 to for the whisker and for the diagram. First, let's make this and give them the value and the triangle above this thing, and wait a minute, and this the I don't know what is that. And here is the median. This is this is the P25, which is the quartile 1. This is the quartile 3, the P75, and this is the median. This is the minimum, which is the first value 5, and the maximum with the value of 23, and the first quartile, as we get here, the first one we get is 8 here. The third thing we get is the third quartile, which is the 17 here, and the median, which is the 13.5. Stem and leaf display. A stem and leaf display is an organized diagram showing the relative position of every element in the dataset such that the leading digits become the stem and the trailing digits becomes the leaf. This is done doing this. We have here the datasets. Let's arrange them and separate the single digits with a leading digits of 0, meaning 0, 0, 0, 1, 0, 3, 0, 3, 0, 4, 0, 4. And separate also the who has the leading digit of 1, which is here, who has separate the leading digit with 2 and 3. In doing the stem and leaf display diagram, we will use this, and here is the side of the stem, and here is the side of leaf. Oops, error. F dot F. And here we have the leading digits, which is the 0, 1, 2, 3. As you can see, we have here the leading digit of 0 and 1 here, 2 here, and 3. And first the 0, 0, 1, 0, 2, 0, 3, 0, 3, and so on and so forth. And the leading digit and the leaf of 1 here, the 10, 10, 12, 12, 12, 13, 14, 15, 18, and the 4 and 24 and 30. That's how to make a stem and leaf display. Third topic is the normal distribution. A normal distribution, named as the Gaussian distribution, is a continuous probability distribution which is drawn graphically by a smooth bell-shaped curve called the normal curve, having an area under it which is equal to 1. Properties of a normal distribution. Any normal distribution has the following properties. The total area under the normal curve is 1. The three measures of central tendency given by the mean, median, and the mode are all equal. It is symmetric with respect to the vertical line x equal mean, or x is mean. The curve is asymptotic with respect to the horizontal axis in both directions. This is the diagram for the normal distribution. We have here the area of this and this as the 34%, and here in 13.5%. And so if we add this 34% and 34%, you have the 68%, which is the area of this, and here you have the percent of area of 95% of the data, and all of them is 99.7% of the data. The portion of values in a given dataset which is normally distributed is based on the mean and standard deviation of the dataset. That is, about 68 of the observation fall within one standard deviation away from the mean. About 95% of the observation fall within two standard deviations away from the mean, and about 99.7% of the observation fall within three standard deviations away from the mean. A standard normal distribution is a distribution of a random variable with mean 0 and the standard deviation equal to 1. A random variable x with mean and standard deviation can be transformed into a standard normal variable z with mean 0 and standard deviation equal to 1 by using the formula z equals x minus the mean, and the standard deviation. Or the bias, I forgot. For example, the test score of a physics class with 800 students are distributed normally with a mean of 75 and a standard deviation of a 7. Let's draw first the question: what percentage of the class has a test score between 68 and 84? B. The percentage of the class that has a score of 75 and 18. Let's draw a diagram here. It's just like the diagram before or earlier. And here is the data sets, which is next solution. Let's bring him here. What percentage of the class has a test score between 88 and 82? Solution: P. 68 is less than or equal to Z and greater than or equal to 82. We can get this by adding the area of 68 to 82, which is this, the 34% and the 34%. We have, by adding that, we have the 68.268% of the data of this area. The percentage of the class that has a score of 75 and 89, we will find the area of 75 to 89, which is here. This P. 75 is less than or equal to and greater than or equal to 89. The sum is 47.5%. Fourth topic is the linear regression and correlation. Correlation analysis is a method used to measure the degree of relationship or association between two or more variables. Types of correlation. Positive correlation, a direct relationship between two variables exists. That is, as one variable increases or decreases, the other also increases or decreases. Negative correlation, an inverse relationship exists between the variables. Here, one variable increases as the other decreases, or vice versa. Zero correlation exists when score is one variable tend to score neither systematically high nor systematically low in the other variable. It indicates that there is no correlation between the variables. The points in the scatter diagram are in random manner. Correlation coefficient. coefficient. We have here the data sets of x with the value of 1, 2, 3, 4, 5, 6, and y with the value of 2, 4, 7, 9, 12, 14. This is an example. Let's make this is the value of x and the value of y. We have here the xy, which is we're going to multiply them, the x value to the y value. 1 times multiply to 2 equals 2. 2 multiplied to 4, 8. 3 multiplied to 7, 21. 4 multiplied to 9, 36. 5 multiplied to 12, 60. 6 multiplied to 14, 81. And here is the square x squared and y x squared. We will in here in x squared we will multiply the x value to itself. 1 multiplied to 1 is 1. 2 multiplied to 2 is 4. 3 multiplied to 3 is 9, and so on. We are going to the same solution to the y value. We are going to multiply the y value to itself. 2 multiplied to 2 is 4. 4 multiplied to 4 is 16. 7 multiplied to 7 is 49, and so on. And here is this red shaded numbers is the sum of the y of the this is the sum. This is the sum of y value, and this is the sum of this is the sum of y value, and this is the sum of x value. This is also the sum of the product of x and y value. This is the sum of x squared, and this is the sum of y x squared. We are going to need this. We need this sum. This is the formula we are going to use. Here is the solution. N is the data sets, the number of data sets, 1, 2, 3, 4, 5, 6, and x, and this is the sum of x and y, this, which is the 211, minus to the x, to the sum of x, and multiply to the sum of y, which is the 21 and 48, 21 and 48, divided by 2 to the square root of 6 multiplied to 91, which is the n, and the sum of x squared. Subtract 2 to the sum of x, which is 31, multiply to the exponent of 2, which is squared, and the 6, the n, 6 multiply to the sum of y squared, which is 490, subtract 2 the sum of y value, which is 48, and multiply to 2 the squared. And here is the solution. This is the product. This is the product of this. This is the product of this. This is also the product of this, 6 multiplied to 91. This is the product of 21 plus 21. This is the product. I'm sorry kung mayroong we just add this. And this is the sum, the product of 6 multiplied to 490. Correction for this is 441. We multiply this to 2. That's the product and the sum. And this is the difference of 1266 minus 1008. And this is also the difference of 546 minus 441. This is the difference also of 2940 and minus 2304. We will multiply this in order to get answer. And here is the multiply, and this is the square root of 66,780, and here is the answer. It is a positive 0.998. So that's how you get the correlation coefficient. Next, the linear regression describes the process of estimating the relationship between two variables. The relationship is estimated by fitting a straight line through a given data. The least squares method is useful in determining the equation of the line that best fit the data. This line is known as the regression line, which keeps the prediction errors to be a minimum. It is given by the equation y equals a plus bx, where y is the predicted value, b is the regression value or the slope of the line, a is the y-intercept of the line, which is computed as a equals y subtract to bx, where this symbol is the mean of x values and this symbol is the mean of y values. To find the slope b is equal to n multiplied to the sum of x and y subtract to the product of x and y to the product of the sum of x and the sum of y divided it to n multiplied to the sum of x squared subtract to the sum of x and multiply to 2. This is the formula for finding the slope. Next, we have here, for example, we have here the data value of x 1 2 3 4 5 6 7 and y value with 15 3.8 6.7 9.0 11.2 13.6 and 16. You have here the table for the x value and the y value, and x and y value and the x squared. It's just like what we did earlier. This is also the product of x and y, multiplying the x value to the y value. And here is the x squared. It is done by multiplying the x value to itself. This is the product of x value, which is 28. This is the product, the sum of y value, which is 61.8, and the sum of x y, which is 314.8, and the sum of x squared, which is 140. We are going to use this for the solution. First, let's find the slope. This is the formula we are going to use. B. N is the 7, which is, we have the value of set, which is 7 1 2 3 4 5 6 7, and the x and the sum of x and y, which is the 314.8, and subtract it to the sum of x and to the sum of y. We have 28 and 61.8, and divided it to 7, which is the n, and the sum of x squared, which is 140, and subtract it to the x value, to the sum of x value, and multiply it to 2. This is the product of 7 of this, and this is the product of this, and we have also the product of 7 multiplied to 140, and the product of multiplying 28 to itself. Now we are going to subtract it to. We subtract this, and we have the 473.2, and we subtract this, we have the 196, and this is the answer, 2.412285.7. Now let's find the y-intercept. We have the formula. We're going to use this formula to find the y-intercept. This y is the mean of the y value, which is the 8.83, and this is the our b, which is this, and the mean of x value, which is 4. Now let's multiply this. We have the 9.66 and subtract them, and we have the negative 0.83. Now let's try them. Let's use this formula to check them. We have a is here, this is negative, the negative 0.83 plus 2.41.7 and the x value. Let's try them. Y equals to 0.83, this is negative, I'm sorry, plus 241 and 4 times 2. The 2 is the second. This is to get this second value of y, which is the 3.8. This is the 2. This is the x to this, and the answer is 3.99. It is not far from 3.8, so that is a thing.